Howdy, my name is Ritik and today I'll be presenting you the Milestone 5 AetherMart semester project. Today we'll be going through hybrid data architectures and NoSQL integration in advanced data management for our AetherMart project. The agenda for today is that we'll first provide a brief recap of high availability architecture we finalized in Milestone 4. We will then transition to the core theoretical component of Milestone 5, differentiating data lakes and data warehouses. This leads directly into our hybrid data architecture proposal for my AetherMart project. The second half is the technical demonstration covering the MongoDB proof of concept and Python-based ETL process, followed by a critical discussion on security in a heterogeneous environment. Finally, we'll conclude with the mandatory AI usage, disclosure, and reflection. To transition from milestone 4, let's quickly revisit our foundation. In the previous milestone, we successfully deployed a highly available 3-node MariaDB Galera cluster on AWS EC2. This cluster provides the transactional core of AetherMart, ensuring asset compliance, high availability, and zero data loss for all critical data like orders and financial records. However, our business continues to generate complex unstructured data, primarily in the form of product reviews. The rigid row-based structure of SQL is simply inefficient and slow for handling this type of flexible high-volume data. To solve this, we must evolve into a hybrid system. Before proposing our solution, it is essential to understand the modern data landscape. We differentiate between data warehouse and data lake. Data warehouse, think of this as a highly organized library. It stores structured, clean, and filtered data. It uses schema on write, meaning we enforce a strict structure on the data before it's stored. It is built to answer known questions for business intelligence. However, the data lake on the other side is like uh, the ultimate reservoir. It stores all kinds of data, structured, semi-structured, and unstructured, in its raw native format. It uses schema on read, applying structure only when an analyst needs to query it. It is built for discovery and new insights, typically for data science and machine learning. Our MariaDB cluster serves as a transactional source of truth that feeds both of these potential future problems. Future platforms, sorry. So I have added this over here. So it provides an analogy, a clean, organized library, a vast natural lake of raw water. And the typical questions while using data warehouse will be what were our total sales per category? And for data lake, what new patterns can we find in the web logs? MariaDB snapshots so periodic full and incremental dumps will be there in the data lake. Minimal ingestion transform, schema on read approach, social media data, unstructured and public content, user session logs, click streams, all will use data lake as the management. And for data modeling, data governance, ETL and cleansing, BI and reporting, customer segmentation, we'll be using data warehouse. Our solution, hybrid data architecture proposal, using the right tool for the right job strategy. The AetherMart application sends orders, user registrations, and payments directly into our MariaDB Galera cluster for secure processing. And critically, the application sends product reviews, session logs, and feedback directly to MongoDB. This bypasses the SQL rigidity, allowing for rapid schema evolution. We created a bridge using Python ETL scripts to perform initial data migration and ongoing synchronization between the two systems. Uh, so we'll be using NoSQL to handle the different types of data. Uh, for the reviews table, for example, we'll have images, text-based or video-based inputs. So just handling it through MariaDB won't be possible. That's why we'll be using NoSQL for that. And the model that we have chosen here is MongoDB. And we'll be storing the data in the form of documents, JSON documents. So for the proof of concept, we chose MongoDB, a document database, due to its perfect fit for our JSON-like review data. This integrates directly with our existing AWS EC2 instance. Uh, so I'll quickly walk you through the README document that I prepared. For the installation process, on our EC2, we provisioned a new Ubuntu uh, OS version, and we opened the port 27017. These are the commands that uh, we'll be using to install, that I have used to install MongoDB on my instance. And so I took the help of Gen AI. I specifically used Claude AI for helping me install this. Uh, I was facing various issues while installation, and the debugging part is also included in this README document. For example, we were using Ubuntu version 24.04, but um, the Claude AI was just giving instructions for 22.04 or 20.04. So in that case, we had to update all the packages. These are all the steps that I followed for setting up the MongoDB server on Mongo database on the server, the cluster specifically. So this was so I created an environment specifically for MongoDB. I used these details and I created a new database called uh, NoSQL, AetherMart underscore NoSQL, and I did test the connection. I have attached all the snippets for these, like you can see here, AetherMart NoSQL. And this has the user AetherMart and password student pass 123 exclamation, and these are the steps that I have followed, and I have attached all the snippets while I was going through these. Moving on. So this is the final output where we connected to MariaDB, and uh, so I use the Python scripts. Okay. So for this, what steps I followed is that first we'll take all the MariaDB data, convert it into a JSON document, JSON format, and then use that JSON to import that data onto the MariaDB, and then perform CRUD operations on that table. So these are all the scripts that I have used. So export data from MariaDB to JSON. This is the script that I used. I'll quickly walk you through the script. So we first we'll connect to our MariaDB server that we have, and we'll convert and perform all these operations that we were using while generating the data. Just a reminder that whatever we are whatever data that we are using now is from the robust ETL pipeline from Milestone 4. So it's clean data, and it's taken from the staging tables. So here it's converting the data into these formats, the JSON objects, like we wanted. Transform to JSON structure. Uh, the review. This is the review for the reviews table. So I use this data first to convert it into a JSON format, and then I use the script to convert that JSON data and load it to MongoDB database, the AetherMart underscore NoSQL DB. And like I earlier said that opened the port 27017 from the security group for connection ease. So this is the code that I used for converting the JSON to import the JSON into the DB. Uh, while I was going through this, I faced several errors, and each time I was facing those errors, I had to debug it by constantly training the Claude AI. Once that was done, this is the snippet of MariaDB to JSON export utility, exporting customers to JSON. Found 100 customers in MariaDB, exported 100 customers. Found 28 reviews in MariaDB, exported 28 reviews. Found 50 products in MariaDB, exported 50 product attributes. So this is something that I um, this meant the success of transforming the MariaDB data into JSON formats. Then for JSON to MongoDB import utility, when I ran the code, so uh, attempting to connect to MongoDB connection, first it was testing the connection, which was successful, and then it loaded 100 records, inserted 100 records for the customer, 50 product records for the product, and loaded and inserted 50 like we had earlier, and 28 for the reviews. So all the JSON was successfully loaded. So while facing connection authentication issues, this README document even provides all the debugging steps that I followed because I was constantly facing connection issues because it was not able to authenticate it. So these all steps to switch to the admin first, like using Mongoose to connect to the MongoDB, and then switching to the admin and resetting the admin details, the user details. Finally, once this was done, I ran the CRUD operations file, CRUD operations script. I quickly show that. This was the script that I used to perform the CRUD operations. So it's creating operations, uh, create a new customer created with an ID, uh, create multiple reviews, and then the read operations. The customer that was created is being read here. Same for the reviews over here. Then the update operations. The customers and the reviews are being updated. I'll show you all the final outputs after running the script, what I had received. Uh, this is for the delete operations. So when I ran the Python MongoDB CRUD file, the script, these were all the operations that we just went through. The CRUD operations: insert a new customer. The customer is created with this ID, and the customer ID is 9999. Insert multiple reviews, inserted IDs. Customer ID is so it's reading here. Customer ID 1, Jacob, Tim Powell, email none, H, price at example.net for customer ID 3. Now we want to read the customer that we created. So it is successfully reading this customer. Then for the reviews with rating greater than equal to 4, it is reading all these files, all these JSON objects successfully. So over here, I wanted to highlight that earlier for MariaDB, we had everything in the rows format. Now we have everything in a JSON object. Customer names and emails only projection. So this is something that I got after running the scripts. Update operations. You get the gist, right? So, and this is the delete. So all CRUD operations were completed successfully. Coming back to the uh, PPT. So I showed you ETL migrating SQL data to NoSQL. So first we exported data from MariaDB, imported data into MongoDB, and the outcome and benefits: this method facilitates flexible and consistent storage. It is designed to handle unstructured review data efficiently. The process requires minimal manual intervention. We even saw the CRUD and advanced query demo. The script MongoDB CRUD.py illustrates MongoDB's CRUD and advanced querying capabilities. Create operations demonstrates create one customer for single customer creation. These we went through each of these individually. Aggregation pipeline: aggregate average rating by product to compute average product ratings efficiently, leveraging MongoDB's aggregation pipeline. And performance. So I just wanted to quickly show you the performance insights as well. So I ran a query, right? So For the performance query I ran, okay, it is not coming up, so maybe I can run it again. So here, as you can see, once everything was done, I wanted to compare MariaDB and MongoDB. So I wrote this script where uh, which tests the performance of each of these query operations. So we started off with simple select statements. So this is the code where it starts with the comparison, and then I performed 10 tests over here. We started off with simple select query, and then we had where clause, range query, count aggregation, group by aggregation, text search, join operations, insert operations, update operations, complex aggregations. So here you can see the time taken by MongoDB and the time taken by MariaDB. So here for the 5 records, MariaDB is the winner. Where clause, MariaDB is the winner. Similarly, for insert operations, MongoDB is the winner. And for the update operations, it's a tie. And for complex aggregations, it's MariaDB. Technically, over here, if we just deep dive into it, so 502 milliseconds, that means MongoDB is lightly, or like it has a quite very slight edge over MariaDB. So this is something that I wanted to show you. And moving on, if I move back to the README document, this is the performance testing comparison, MariaDB versus MongoDB. So when I had ran this earlier, it was showing that insert operations MongoDB is faster and simple select also MongoDB is faster. Well, that happens every time. So why MariaDB won most tests? Because the dataset size is small right now. Uh, our current dataset is relatively small. It has few thousand customers, few thousand reviews, and limited products. Index queries, MariaDB won on the queries that were simple lookups by IDs, range queries with indexes, aggregations on indexed columns, joins. Uh, MariaDB has been optimized for 25 plus years for these exact operations. It's a mature, battle tested system. MongoDB's advantages appear at scale. MongoDB excels when millions or billions of documents, not just thousands. So ours is still hundreds. So if we have millions or billions of documents, MongoDB's scalability and performance testing can be proved. High write throughput, thousands of writes per second, distributed or sharded data, multi-server, flexible schema, documents with varying structures, horizontal, adding more servers. So key concepts were small data size, at scale millions of records, MongoDB is better, and for small data size, MariaDB is the winner. MongoDB's real advantages are bulk inserts. It can insert 50,000 plus docs per second. Nested data, one query versus multiple JSONs. MariaDB's real advantages: complex joins, small data sets, ACID transactions, referential integrity. So this shows that we should evaluate what to use when, the polyglot persistence concept. that we learned in the class. So NoSQL database architectural evaluation for AetherMart, database selection rationale, why MongoDB for AetherMart, primary reasons, flexible schema design, document oriented model, horizontal scalability, performance characteristics. And architectural considerations, document structure, we used the JSON structure. Benefits of this design were single query retrieves complete customer context, reduces need for joins across multiple tables, improves read performance for customer facing operations, natural representation of one to many relationships. Similarly, this document has the indexing strategy, critical indexes for AetherMart, customer collection, products collection, and reviews collection. For index considerations, compound indexes for common query patterns, text indexes for search functionality, careful balance between read performance and write overhead, regular index performance monitoring. Scalability architecture, horizontal scaling strategy, sharding by customer region, replica sets for high availability, capacity planning, ideal use cases for AetherMart's multi-channel data, product catalog management. Why NoSQL excels is because they have varying attributes, rapid changes, nested data, search optimization. Customer 360 view. Why NoSQL excels is because of the unified profile, behavioral data, personalization, multi-channel activities. We can use it through web, mobile app, in-store purchases, unified. This will lead to faster personalization, engine queries, real-time customer segmentation, single source of truth for customer data, improved customer experience through channels. Reviews and user-generated content. Why NoSQL excels is because they have variable content, text, images, videos, ratings, all in one document. High write volume, thousands of reviews can be written daily without any issues. Nested metadata, verified purchase, helpful votes, moderation status, fast aggregations, average rating, sentiment analysis. So this is again the difference or comparison between the relational versus the MongoDB. Uh, when MongoDB is better, we just discussed everything, right? Advantages of MongoDB and EtherMart: flexibility, add new product types without database changes, evolve customer data model as business grows, rapidly prototyping and feature development, performance, fast reads for product browsing, high write throughput for reviews and events, efficient aggregation pipeline for analytics, scalability, developer productivity. We just discussed it some time back. Uh, Coming back to the PPT, so security in heterogeneous environment, PII duplication risk. The personal identifiable information is duplicated across SQL and NoSQL databases, increasing the risk of data breaches due to the use of ETL processes. Configuration drift challenges. Emphasis on MariaDB security may lead to overlooked hardening of MongoDB, thereby increasing the risk of misconfigurations or vulnerabilities. Expanding attack surface, integrating diverse databases like MongoDB and MariaDB expands the potential attack surface, necessitating advanced defense strategies, managing hybrid ecosystems, effectively administrating hybrid environments demands heightened awareness and vigilance to mitigate security threats across different systems. Network isolation. We mitigated these risks with three best practices. Network isolation. We used a private IP address for all inter-EC2 communication, both MariaDB and MongoDB. No public IPs are used for backend connections. security groups, we implemented strict firewall rules, only allowing inbound traffic on port 3306 for MariaDB and 27017 for MongoDB, only from the private IP of the application server. Least privilege, both the student user and the AetherMart user, the users that we were using, were granted only minimal permission required for respective databases, severely limiting the damage a compromised account could cause. So AI usage, disclosure, and reflection. I used uh, Claude AI, Gemini, and ChatGPT for the entire Milestone, as well as Gamma.ai for creating the presentation. Uh, the AI helped generate boilerplate Python code for ETL scripts and initial CRUD templates. It also aided in structuring the theoretical definitions for data lake, data warehouse, and what their comparison and analysis was. I had to manually correct and adapt the generated code, particularly for database specific syntax, and to ensure proper error handling and connection security, such as explicitly defining the auth score is equal to admin in the MongoDB connection string. Additionally, I had to debug wherever I was facing the issues. Lessons learned is that the AI serves as an excellent accelerator, providing the first 80% of the work. However, human expertise is essential for the final 20% to know if it's the correct uh, stuff, whatever GenAI is giving, specifically for security environment specific configurations. Conclusion and next steps. In conclusion, Milestone 5 successfully transitioned AetherMart from a purely relational system to a secure hybrid data architecture that can now handle high integrity transactions and high volume unstructured data simultaneously. The NoSQL POC is fully functional and validated for performance. This foundation sets up perfectly for our final phase, milestone 6, where we will integrate the most advanced concepts, the vector database to power AI driven features like semantic search and recommendation engines. Thank you so much, and I hope you understood whatever I was trying to say. Please reach out if you have any questions. Have a great day.